Thank you so much for joining this channel. We are in day 16 now. So from day 16, we have migrated from Ollama to Azure AI. Please visit the setup video of how to set up the Azure AI or Azure Cloud Foundry, how we have done the movement from Ollama to Azure AI. So day 0 to day 15 targeted local Ollama just to get a clear concept on Agentic AI. But since the things are getting complex, so we're moving from to Azure AI from the day 16. But before you visit this day 16, at least visit the day 15.5, which is a foundation for the day 16 onwards. In the future also we will use AWS GCP also, but we will focus now on the Azure Cloud, Azure AI Foundry. So once you've done the visit of day 15.5, then you come to here. Here we are actually migrating an AI agent. So you can say we are developing an AI agent. The same what we have done earlier, multi-agent concept, but here Ollama is replaced by the cloud. Cloud will give you the answer. So .NET Core, Semantic Kernel, that is our baseline, and Azure OpenAI is a replacement of Ollama now. So you can see it is not only, it is now no longer a learning platform. Plus also we are building the enterprise cloud agentic architecture. So this already been discussed in the 15.5 also, but those who haven't visited, for them actually why we are moving, it is a limited hardware, slow inferences, no enterprise scaling. Evidently in the cloud, give any product, cloud has some additional facility like scalable, high availability. Even though you are not using right now all the features, but the reason for movement to the cloud is that you can leverage it at the right time when the right time comes, right? So right now we are only using the cloud, but this feature will be used as we move to the in the complexity in the upcoming days. So now the local Ollama, those who haven't done, just go through that. This is the foundation was Semantic Kernel, Ollama, local LLM. But now in the Cloud Foundry, we are actually replaced this Ollama with AI Foundry, and the local LLM is another replaced by this Azure OpenAI models. OpenAI models is like GPT-4, GPT 5.1, 5.2, those which you are using in the Chat GPT. The same model will be used through Azure AI Cloud Foundry through an API endpoint. Because you know that Ollama only can give you some result, but Ollama cannot execute. That's the reason the Agentic AI comes into picture, which will take the ownership of executing something on behalf of you. Ollama will be a part of that Agentic AI. So you can say brain. So day 16 architecture, user will send a request, agent runtime will call the router will decide if there are multiple agents, which are the agents you needed actually for execution. If there are more than one, right, based on the input, then you can use the parallel executor. Even if there are 4 or 5 agents, but you are selecting only one, even though you are running parallel executor, only one will be executed. But parallel execution means if it is independent, then you can execute parallelly. If it is interdependent, then we have to wait for the input of the first agent, which will be output for the next agent, right? But think this is the overall architecture. You can tweak it as per your requirement. Runtime, router, parallel executor, then code review. We are using 3 agents: code review agent, complexity agent, security agent, and finally this all agent will talk to the Azure OpenAI, a cloud foundry, which will internally call the OpenAI models like GPT 4.0, 5.0, 5.2, but we are using GPT 4.0 mini for demo purpose. So why in this enterprise, you know, when you are introducing the Ollama, we are replacing Ollama with cloud. So there is a approach, or you can say intention is to make enterprise so that you can make real time production ready application. So OpenAI integration we are doing, right. Earlier with local LLM we are using. Then prompt caching. If the prompt already given you the result, there is no point in execute the same prompt again, right? So caching also been introduced. If there are multiple agents, parallel agent can be executed. That we already done in the with Ollama also, but we are leveraging that. Telemetry we already discussed in the day 14. The same thing has been introduced over here. Modular infrastructure layer, so the architecture has been maintained so that it can be more testable, it can be more separation of concept, all the things are in place. So kernel factory, you know that even when you are using multiple agents, so all agents actually talk to the cloud, right? Cloud OpenAI models through an endpoint and the API key, so there is no need to copy the same code for each and every agent. So we are following some design principles, and we are creating a factory pattern which will be called by each individual agent so that you can use the common shared code. Caching, definitely we are reducing the cost of using the cloud AI if it is not required, because if you are executing the same prompt, you can use it, right, whatever result you already achieved in the previous call, so it will reduce the cost and latency. Parallel execution task that will allow multiple agents to analyze code simultaneously, so that is it will reduce the overall turnaround time. Telemetry observability, you know that it's very difficult to debug any agentic AI application, but if you add some telemetry observability in the normal application also, this will help you to troubleshoot your issues. You can fix the things, you can navigate, you can create the ticket based on that. So this will help you for this monitoring purpose. So what we will demo, we will take a code file order.service that we already using in the other files. Then we will select the agents. We already discussed the 3 agents we are using. Then we will execute the parallelly. Then we will allow, or you can say leverage the Azure Foundry, which will analyze this all agents. Okay, using the deployed model, that is we are using GPT 4.0, and whatever result will come, all result will be clubbed together, and the aggregate result will be displayed to the user. So once this is done, in day 17 we'll discuss this. Let's concentrate on the day 16 demo. Discuss what to we are targeting actually in the day 16. So day 16 is nothing but full-fledged using of Azure AI with multiple agents, where we will show so many features like that we already discussed: parallel execution, using of the agent runtime, router, telemetry, multi-agent. So all things that we are trying to club together whatever we have discussed from day 0 to day 9 or day 10, where individual agent has been used. From day 9 we have introduced the multiple agent but with Ollama, but in day 16 we are introducing the same multiple agents with additional capabilities what we discussed earlier, all clubbed together with the Cloud Foundry. So this is our stack. Only the Ollama has been replaced, and the Ollama's LLM local model has been replaced by Foundry and OpenAI. OpenAI, when I say, is we are taking GPT 4.0, Gemini, sorry, GPT 4.0. So local agent is nothing but a local agent. Now it is a cloud infrastructure. So recap, I always do the recap so that you understand from where we started. .NET application, semantic, Ollama, we have done multi-agent, tool plugin, observability, performance optimization, we have done. This is the architecture earlier till day 14. Why we have moved that we discussed in the day 15.5 also, that limited computing power slower, because we are now not only a local application, it is like enterprise architecture, and to support that we need a good infrastructure that only can be provided by the cloud. So these are the reason that why we are using the cloud AI. Advantage, why we have moved, and advantage almost close, but even we have make a separate section: scalable, enterprise integrated, enterprise security. Azure is giving so many things, right, so that you can use. We are not using right now, but at least you understand what you can use, and that we can show slowly. So now we have already discussed this flow. This is the baseline flow. If you understand this, then on top of that you just correlate what has been changed. Semantic Kernel, Foundry, OpenAI response. So these two are addition and replacement of Ollama and LLM model, local LLM model. So now it is a AI workload enterprise level. So what we are doing, we are taking the user request, we will call the runtime, runtime will call the router will decide which one to choose, and then if you choose more than one, it will be executed parallelly. As of now, we are taking the 3. You can increase it to more also, and finally it will call all the individual agent will talk to the OpenAI, Azure Cloud Foundry, and Cloud Foundry will talk to the OpenAI, which is a GPT-4 model. This is the cloud AI models. Kernel factory. So this is actually where we are creating this connectivity with the cloud, common code that we will show in the demo. The same thing we have done for the local LLM also. The only replacement is the local LLM model ID is replaced by the endpoint model name. Those things we will show. We already showed in 15.5 also. Same thing, nothing else. Prompt caching we already discussed that to reduce the cost and everything if the same prompt you are executing multiple times. Parallelism, that is only for faster scalability and improved system performance. Observability is in execution time, model latency, request processing. So we are using stopwatch also. Is in how much time agent is executed, is there latency or not, request processing time, all will be covered into the observability. After creating the resources, deploy a model, right? So we are deploying the model, then only the model can do the analysis for me. So this is the model details. We will show in the demo also. This model will be called to the API call. API call means that API endpoint will be given by the Azure Cloud Foundry. The demo is we will do the same thing: read code, sample, agent router, select, agent runtime parallel, and finally aggregate it. Key concept: learn how to migrate AI agent to Azure, how to integrate Azure AI with semantic kernel, cloud AI architecture, prompt caching, parallel agent, observability. All these things which we discussed earlier individually. Now we are trying to club all those things more and more. Same thing we discussed the diagram. Just see that runtime, router, parallel executor, prompt caching. So this is the older one when I started, but now it is improvement in terms of architecture. That infrastructure will contain this kernel factory, prompt cache, telemetry collector. These are the agents which will work on the sample code. All these 3 will be executed parallelly by this parallel executor. Parallel executor will be called by the router, because router will decide which agent to work, and router will be, all things will be orchestrated. Everything the project will be the runtime. So this is the overall flow that we already discussed earlier. So this has been moved or upgrade to this next level. You can see orchestration earlier, router and runtime. There is no exec parallel, so that we introduced infrastructure only the kernel factory. Now we introduced prompt cache and the telemetry, and remaining these are already same. So it's a demo time. We will show how Azure OpenAI actually helping us to give a decision, how the parallel agents are working, how the prompt caching is working, why the telemetry is working, how the router is working. So these things will be shown. It is shown already in the earlier days, but it will shown in a package format. So I think we are done with this discussion in the technical dive. Let's go to the final demo. So now we came to the demo. You can see that at day 16 we are targeting whatever we have discussed in the PDF, in the technical dive section and the introductory section in the PPT. The same architecture has been placed over here. We are taking 3 agents. 3 agents have a common method: execute, async, right? So that the design principle has been followed. We are not depending on directly on this concrete class. We will depend on this interface. So you can say open for extension, close for modification. So we will not modify anything. We can add more and more agent, implementing iAgent. That is the first design principle has been used. Infrastructure, as I said, this connectivity we are using right now. I already created this endpoint and API key. How to create this endpoint and API key, that has been discussed in the day 15.5. You can check there. from starting from Azure setup and everything. Prompt catchy is like normal catchy. We are just using caching. Means here within dictionary you can use Redis catch and everything that we haven't introduced, but as of now it is a dictionary only. Telemetry, just a console dot write line, but you can use it app insight or Azure monitor log analytics, all those things. But this is something you can log. If you want a detailed discussion on this telemetry, visit day 14. Final result will come agent name. Agent name is this three agent is working, right? Sorry, why it gone? Free agent. And the result will come from the Ollama, this Azure OpenAI. Telemetry event we are not using right now. We are putting a console.log. Agent router, as I said, router will decide which agent to correct. So right now what we are doing, if the request contain the security, then we are taking all the agents. If it doesn't contain the security, we are taking only the code review and the complexity, because security is not tickets. You can write your own logic, but this is a simple logic. So this router will be called by the runtime. So runtime is the orchestrator which will call the router, decide which agent to call. Once this agent has been decided, then an agent will actually make the call of this individual agents. But how they will be executed? They will be executed parallelly. So what will happen? So the task will contain all the calls. And what is the format of this task? It is a I task list of agent result, right? I enumerable. We are enumerating, right, all the agents, and all will be executed parallelly. And when all are done, then only this task.when will be executed, and the result will be displayed. So this is the file. This is the file that we are taking, which will give you that security issue, any conditional issue, code or anything. So complexity it will be checked. So program.c is what we are doing. We are creating the kernel factory, because this is the connectivity with the required for the cloud, telemetry execution, prompt catchy. Then we are calling all the agents. Then agent will pass to the router. Then router will pass to the runtime. We will read the file. Then this result runtime will call the run async. So you can see we are passing review code and security. If I put only review code, only the first two will be executed. Means code review agent and complexity. But we have added the review code and security, so all three will be executed. So you can modify it. So runtime will call the run asyncs, and this will internally call the parallel execute. First it will call the router, and then it will call the runtime. Hope this is clear, the flow. So let's execute this code. So agents are initialized, router is initialized, file has been read. Now we'll call this. So now we'll check what is the request. Request is review code and security. So if I add the security, all three will be taken. If the security is not there, then only the first two, complexity and the code review. So agents, three agents are there. Now these agents will be called individual agent, but to their parallel executor. So how it will go? So if I put a debug point over here, if I put a debug point over here, so we'll see how it is executing. It came first to the code review agent. Code review agent will take this system prompt. It will check if the catchy or not. It is not. Then we are checking that telemetry parts. We are checking how much time it is executing. For agent execution, we are taking the stopwatch also. So now that is executing parallelly. Now the second complexity agent also been called. Now we are going to the security agent also. All are parallelly. So now this security agent came up with the result. So all result has came. Three result from three different agent, and let's run it. So now you can see code review agent details, complexity agent came. Space complexity, time complexity, summary. I think this is security. One password variable is there, right? So the last are the security, inefficient input validation, error handling, potential for logging sensitive information, hard coded password. So all has came. Time complexity is order of one, space complexity is order of one. So hope you get to know how the cloud AI is giving all the information, how this agent multiple agent is working together. We are leverage all the features, most probably all the features like telemetry, parallel execution, runtime, okay, and Azure OpenAI models, Azure AI Foundry. So hope you get to know how to build a application, multi-agent application using cloud AI. So thank you so much.